more conditional expressions. Originally, we just stated the ones that were exactly like math. Here I have a longer table with the math symbol and then the C# expression. As we've seen, less than is exactly the same, and same with greater than. But the less than or equal single symbol does not appear on a keyboard, so we need both a less than and an equal. That is less than or equal in C#, and similarly for greater than or equal here, we have greater than and then equal. The next one is the most problematic. Of course, you're used for asserting equality with an equal sign in math, but we've already used an equal sign in C# to mean assignment. So we have to do something else, and to have it still have to do with an equal sign, we just double it. Equal, equal. And finally, not equal, which you see in math with this slash through the equal. We can't superimpose things, and it turns out that the symbol going way back to C many years ago is exclamation point equal. All of these symbols here, from here to here in C# that have two characters, cannot have a space between them. They must be right together to be interpreted correctly. If you try to test for equality with a single equal sign, you will make a mistake. Hopefully, it will generally cause an error in the compiler to help you find it, but maybe not always. Let's start with C#. Let's suppose we've got an int x, and I can say x is equal to 5. And notice that doesn't give me a response, it just assigns the value to x, which we can check. Let's now try x equals 5. What happens now? This is true. And x is, of course, still 5. What about x equals 7? Well, that's false, because x is still 5. So we see here that testing x does not change its value, and when we use the equal, it's an expression with a value true or false. Let's try some other symbols. How about 5 equals x? That's also true. Remember, while the order is important for an assignment, it doesn't matter if you're just testing. Either side can be on either side. Let's try 7 is unequal to x, exclamation equal. True, 7 is not 5. On the other hand, if we try 5 is unequal with the exclamation point equal x, we get false. It is not true that 5 is unequal to 5. And this also works with other types than numbers. We can check with strings. Up equals, let's say u plus p. Oops, that's going to be an error, but let's try it. Yep, because I've got an expression on the side. That's a good thing. It's finding the error, but now I can check the expression on the right here is worked out before the assignment is tested, and it's of course true that if you put a u and a p together, you get up. Let's try a string s, and we'll let it be high. And let's let a string t be capital H, capital I, exclamation point. And we can check if x is the same as t, and it's not. The case is significant. We could change the expression. We should have s dot to upper, which returns a string with uppercase rather than lowercase elements, equal to t. that's true. Let's consider a more substantial example. Pay with overtime. Here's the heading for a function that we would like to write. So we suppose that we have calc weekly wages, which takes two double parameters. One is the total hours worked, and the other is the hourly wage. And we want to return the total pay, which is another double. So think about this. If pay overtime of 1.5 times as much for over 40 hours, how are you going to do it? Well, let's go through it. I declare a variable for the total wages that we're trying to calculate. There are two different cases depending on whether or not there is overtime. If total hours is less than or equal to 40, using this new operator, that means there's no overtime and the total wages are very easily calculated from the hourly wage times the total hours. But that's only one of the cases when the total hours are less than or equal to 40. Else, otherwise, the opposite case, just for ease of following here, we will declare the variable overtime, which is the amount of hours over 40. And then the total wages is slightly more complicated. You get paid the straight hourly wage for your first 40 hours, but then you get paid the overtime rate for the overtime hours. Either way, we've calculated total wages, and at the end, after the if statement, so it always executes, we return the total wages. After that, there's a main program that's your basic get input, calculate, and put out the outputs with one slight wrinkle. So we read in the hours and the wage. We let total be what is returned by the function we've just described. Then we print things out. And you'll notice we're making substitutions here in a string. You see the curly braces. So far, so good, but here we have something different. Inside the curly braces, we have our number indicating which parameter, but the new part now is colon F2. Let's see what happens if we leave that out. So let's try out the program. But let me change it first to make it more familiar. Get rid of this new stuff. And let's run it. Let's suppose that we work 10 hours at $12 an hour. We get $120. Well, that looks okay. Let's try this again. And suppose I have slightly different numbers. Let's suppose that I get paid 10 1/4 an hour, and I work 12 3/4 hours. So 10 1/4 an hour, $12.75 per hour, and my total wages are $130.6875. That is actually the product of these two real numbers, but that's not what you'd be paid. You don't get paid fractions of a cent. What would happen? This .6875 would be rounded to actual cents. It should end at 0.69. That's what the new code is going to do. Let's put these changes, the original form back. And try it again. Let's try 10 1/4 hours. And let's try $12.75 per hour. And the first part comes out the same. But now you will see that the last part ends 0.69. 2 decimal places is appropriate if we're dealing with money. In general, when we have a substitution in braces followed by the location in the parameter list of what you're substituting, it is possible to add a colon and further information about the details of the formatting of the answer. In this case, the code is F for fixed number of decimal places, and then the 2 means show 2 decimal places and round to that number of decimal places. If we try now even our first example, which looked okay, what if we try we worked 10 hours for $12 an hour? You'll see that it comes out looking like money. We show the cents. If it says 2 decimal places here, then you always get them even if they're zeros. Similarly here. Let's also test the rest of the program. We've only tried the path through the program here with the if part because we've never had overtime. So let's now try it again and test the other way. Let's suppose we work 45 hours at $10 an hour to make the arithmetic easy. And what do we get? If it were straight time, it would be $10 times 45 hours would be $450, but it's not. It's $475 because the extra time, the $50, gets multiplied by 1.5 and it becomes 75 that we add up to the time for the first 40 hours. So that is correct. We can play in the C# program here. Let's declare a double x, say, equals 1.2468, and then we can do console.writeLine, and we need a format string. I don't know, we can make it simple, answer. We're going to put our substitution, and with the curly brace, if I just put 0, then if I give it x, we get the full number here, 1.2468. Vary the format, put in the colon. With a fixed number of decimal places, we could try 1 decimal place. And we get 1.2. 468 is not enough to round it up to 1.3. But on the other hand, if I tried this to 3 decimal places, I get 1.247, not 6. Because of the 8 after it, we round up. I want to mention that there are more than one equivalent ways of doing lots of things. There is a variation wages2.cs here, and I'd like you to look at this. In this case, I declare 2 variables, regular hours and overtime. That's how we split up different periods for pay. We still have the same split in the if statement. This is the case where we only have regular hours. So the regular hours are the total hours, the overtime is nothing. The other case, else, is when we are over 40 hours, in which case the regular hours is the full 40, the overtime is just like we had in the last version, total hours minus 40. In this case, I've unified the calculation, and I can just have a single calculation of the total pay, which here I return immediately. So you get the basic wage for all the regular hours, you get the overtime pay just for the overtime.